Hi guys, right, we're going to get straight back into it. We're still in our next token method, and this time we're going to hopefully get to the end of the tokenizer in this video. First thing is strings. Now in Objo, we only have one type of a string literal, and that is a run of characters flanked either side by the double quote character. Now we're going to support that in Objo, and we're going to call it a raw string literal. That's what we're going to term that token. The other type of strings that we're going to support are called escaped string literals, and they will be flanked by single quotes. But let's tackle the more straightforward Objo-like string first. So if our character matches a double quote, which is what this line here means. Now, in case you aren't familiar with how you write a double quote in Objo, if you make a string with an empty string like that, if you put two double quotes in it, that will count as one double quote. Okay, so Objo will see this as a solitary double quote. We could do something like, if character 34, or if C equals character 34, which is the ASCII character for a double quote. But this is probably, I find it easier to look at. So if the character matches a double quote, then we're going to try and add a raw string literal token. Okay, so let's have a look at this method where that magic happens. So documented as I've become known for doing. So in Objo, just like in Objo, our raw strings begin and end with a double quote. Everything between those two things, including, which is different than Objo, new line characters, will be a string. So Objo, if you don't use the underscore, the line continuation operator at the end, then you can't have like we can't really do multi-line strings in Objo, if I'm honest, without using a concatenation operator. Objo lets you do that. Anything between two double quotes is a single string literal, unless it sees two double quotes next to each other, in which case it considers that to be a double quote, just like Objo does. We call that an escaped double quote. The catch to that is, of course, if the string is just two double quotes, in which case it's an empty string. So that's what we've got to handle in this method. So how do we do that? Right, well, for prettiness sake, first of all, we start by remembering the line number that this begins at. Okay, so I've got original line number here, and we just store the line number. This method assumes that we've already consumed the double quote, okay, in next token, and we're pointing at the next character to evaluate. So what we do is we just keep consuming characters, but we need a couple of flags. First of all, we need to, don't want that, apologies. First of all, we need a flag, which we're going to call terminated. Now that will be set to true when we find a double quote that ends this string. Okay, so we know that yes, okay, this is a successfully terminated raw string literal. We also need another flag called contains escaped quotes, because, and it will become apparent shortly, if we have two double quotes next to each other, I've said that will count as a double quote, but we will need to make that the case when we derive the lexeme for the token. Okay, so both these are false at first. So we have a string C, which is going to be the character, and we enter a loop until we reach the end of the source code or one of these conditions in the loop. So we get the next character to look at and we analyze it. If it's a quote, now here in capitals, this is my convention for a constant, and as you can see down at the bottom, it's the double quote character. Okay, it's just a constant. So if the character is a quote, then we've either hit the end of the string, or if it happens to be two next to each other, this is an escaped double quote. So as this comment says here, if the next one is a double quote, then it's an escaped quote. So we use our method match, which, remember, consumes the character if it matches what we ask it to. So if we match another quote, then we will set the flag saying that this token contains an escaped double quote to true. That logic will come in play later, and we continue the loop. Okay, we keep going, we keep getting more characters because we haven't finished the string yet. Otherwise, if we see a double quote and it's not, there aren't two of them, then we've just terminated the token. Okay, we've just terminated the string. So we say that's true and we exit the loop. Otherwise, what if the character is a new line character? Okay, well, we know that we've standardized all the strings, all the new lines in our source code to the Unix end of line character. So if we see that, then what Objo will do is say, oh, okay, well, this is just a string that spans multiple lines. So that will look like this. Var s equals hello, how are you? Something like that would be, this would be a valid string in Zojo, in Objo. In Zojo, that would be an error, okay? But in Objo, that's going to be allowed. So what we do is we just increment the line number and we carry on. So the only way we exit this loop is if we find an unescaped double quote or we get to the end of the source code. Once we're out the loop, we need to check if it was properly terminated, i.e. did you find a closing quote? If it didn't, so if terminated is false, then we throw an error. Okay, and we say, look, unterminated, right, you're missing a double quote. And the tokenizer will, break at that point, and we'll need to handle that. We'll do a little quick check here for some speed. I mean, you don't want to over-optimize these things until you have to, but this seems like a sensible check. We'll just check to see if this is an empty string. Okay, so is this something like this, an empty string? So if the current location of the pointer is 1 after the token start, then it must be an empty string. So we just add a new Objo token of type string literal starting at token start, and we put the original line number as the starting position of the token. And we don't need a lexeme because there isn't one, because it's an empty string. If it's not an empty string, and then we exit. If it's not an empty string, well, we need to figure out the lexeme. Okay, we need to figure out what are the characters of this string token. So essentially, it's everything between the flanking double quotes. So what we do is we say, okay, well, we take the source code, we take a section of it using the middle extension, and we start 1 after the token start point, because remember the token start point is the opening double quotes. And then we go to the current position, take away the token start, take away 2 to account for the 2 flanking double quotes, right? The math works out, trust me. That will give you the lexeme. And we're going to see this in action a little bit later. Now we've got the lexeme, we just need to check, are there any double quotes next to each other? So are there any escaped double quotes? Because if there are, we want to convert them to just a single quote, because that's what the user intends them to be. Which is why we have this contains escaped quotes flag. We don't technically need this, actually, because what we could do, because all I'm doing is I'm replacing all instances of 2 quotes with 1 quote. We could just do this anyway, but the reason I have this flag is because there's a computational cost to this replace all function. It's fast, it's written in C++ in Zojo's framework, but there's a cost. So if I don't need to do it, I'm not going to. Finally, we just add a new Objo token, which is a string literal starting at the token start, beginning at the original line number, and with the lexeme we compute. Done. Okay. We have string literals now in our tokenizer, and we're going to see this a little bit later. Hopefully in this video if we get time. The next string type is what I mentioned, this escaped string literal. Now, Zojo has no concept of this, but most other languages have it. So you can see this in Python, Ren, a bunch of other stuff will have this kind of syntax. And escaped strings are represented in Objo by a run of characters flanked by single quotes. Okay, this is why we can't use a single quote as a comment in Objo like we do in Zojo, because I'm using the single quote to signify a string. So that's why we only have 2 forward slashes as a comment in our language. So let's take a look at this add escape string literal method. Now I've written lots of documentation here. Now hopefully it's self-explanatory, but essentially a run of characters starting and ending with a single quote is what we are going to term an escaped string literal. Now the special thing about them is that they can contain certain escape sequences. Now an escape sequence is represented by a backslash and then a character. So if you want to include a new line in your string, you can just put a new line in, or you can write \n for new line. You want to include a tab, \t. If you want to actually include a single quote, unlike the raw string literals where we would put 2 double quotes next to each other, that doesn't work for this. If you want to include a single quote in a single quote flanked string, you need to do \, single quote. If you want to include a backslash, because obviously that's going to confuse things because the backslash is a special character, you need to put 2 backslashes. Now remember, if you want to include a single quote or a backslash in a string, you could just use a double quoted string and that will be fine, okay, because it's just a raw string. It's only in these single quote flank strings that things are a little bit different. And finally, I've included this nifty little Unicode code point escape sequence. So basically, if you do a backslash and a U, and then between 1 and 8 hex digits, which represent the code point, you can include any Unicode character you want, emojis, etc. Which I think is more useful than in Zojo, where unless you go into the emoji picker and find it and paste it, you'd have to do a string quote, concatenation sign, then the &U literal, and then the hex numbers, which is a bit ugly. So this should be nicer. So how do we do that? Well, it's actually quite similar to what we just did. Again, we cache the original line number. Then we're going to keep on going till we hit an unescaped single quote, okay, because that will signify the end of this string. Because remember, we're currently pointing at the character after the opening single quote. That's what this method expects. So I've just dimensioned a few, excuse me, a few variables here. Again, another flag to know if we've terminated or not, which starts off as false. And we enter a loop that will definitely end when we get into the source code, but also it will end in a couple of these catches here. So first of all, we get the next character to look at. If it's a single quote, it's the end of the string. We're done. Okay, so we're terminated, true, we exit the loop. That's easy. If we hit a new line character, then just like before, we just carry on. We increment the line number in the tokenizer and we carry on. We can just include a new line. If we see a backslash, then this is the beginning of an escape sequence. So we need to look at the next character coming to see what type of escape sequence. If it's an N, then this is the new line escape sequence. And what we do is to our lexeme, which is a bit different than the last time, because the last time what we did is we just kept gobbling up the characters, and then at the end we figured out what the lexeme must be by using the string middle function. Because of all the escape sequences in this, we can't do that. So as we go along, we need to build the lexeme. So hence why I made a string variable called lexeme up here. So if we've got a \n, that's a new line. So all we do is we add an end of line character to the lexeme. If it's a T, it's a tab. So we add the tab character. If it's another \, then this is an escaped \. So what that means is, I've got an error here. If that's an escape \, so to that we need to add the \ character to our lexeme. If we match a single quote, then this is an escaped single quote. Okay, so we just add a single quote to the lexeme. Now the special case, if we see a U, that means we have got the Unicode escape sequence. So we need to find between 1 and 8 hex digits after that. Otherwise, it's an error. So what we do is we check, is the next character a hex digit? And we've talked about this function we've already defined before, and it will just return true if it's a hex digit. If it's not, we throw an error. If it is, then we need to get them. So to do that, we'll make a new variable called hex, which is a string, which is going to hold these hex characters. And we basically do a loop for a maximum of 8 iterations. And when we find the character that is not a hex digit, we exit the loop. Otherwise, we keep advancing and adding it to our growing hex string. And by the end of this loop, we will have a hex string of the Unicode code point. We must make sure that the character after these hex digits is non-alphanumeric. Okay, because what we don't want is something like okay, we've got that. That would be a valid Unicode code point. And then we see a Z. That doesn't make any sense. Okay, we need a non-alphanumeric character, so we could have like a plus, or we can have, a dot, something like that, but it has to be non-alphanumeric. So we do a little check using this function isAlpha, which I think we've gone over on the previous videos. Yeah, we just use our non-alpha dictionary, this method here, to check if the next character is an alpha. If it is alpha, then it's an error. If we get to this point, then we've got our hex string, and we know we've got that it's valid. So we just need to figure out, well, what is the code point? Okay, those hex digits, what character actually is that? Now, I'm really trying hard to use API 2 in everything I do for Objo. But unfortunately, we need to use one of the, it's not deprecated, but one of the sort of bizarre hybrid API 1/2 functions that's hanging around. So we get the code point by calling this from hex method on an integer and passing it the hex string. That will give us an integer. Then we use this from Unicode code point method on the text type, and we give it the code point, and it will return a character. It will return a text character, but that's interchangeable with string, so we can add that to our lexeme. So basically, if I pass a Unicode code point to this method, I'll get back a character. I really should file a bug report to Objo to ask them to add this to string, but anyway, it works, it's fine. If something goes wrong, so if this code point that we've created and passed to this method is not valid, then we'll get an error. Okay, the framework will throw an error, and we'll catch that, because that must mean there's an invalid code point. And so we'll just throw that as an error. Otherwise, we've got this else here. Oh yes, otherwise we're done with Unicode escapes. This scenario will happen when we've got something like that. Okay, when we've got a backslash and then another character we're not expecting. That's an unrecognized escape sequence, so we'll error out there. If it's any other character, we just add it to the lexeme and we keep going. Okay. Once we've done that, we make sure that it was terminated, which is why we've got the flag. If it wasn't, it's an error. Otherwise, we make the token. We make a new Objo token of type string literal. So that's the same type as the double quote. It doesn't matter to the parser. The parser just needs to know it's a string. So we use the same type, and it starts at token start on original line number with the lexeme we've computed. Okay, and now we have a really robust string system, which is brilliant. Okay, so we're nearly there now. This is the last part of the tokenizer before we can start testing it to make sure I haven't goofed somewhere in my implementation. Finally, it's reserved words, keywords, and identifiers. Okay, it's actually a reasonably big topic, but it's surprisingly easy to implement. So, how do we find out if this is a reserved word like then, else, if, or a special word like a Boolean like true, false, or how do we know if it's just an identifier, so a variable or class name, so name, age, etc. Well, basically, if it's a letter, if the character is a letter, then we will use this identifier or reserved word method. And what that will do is try and make a token that is an identifier token or a reserved word token. And we'll add it to our array of tokens. Now, we talked about StringKit in the last video, or maybe the video before, which is my open source module that we've imported, that does a lot of the heavy lifting to figure out if a character is a letter. But it is really quite difficult to answer that simple question. And Zojo doesn't give us a great solution in its framework. And I'll just briefly show you the code. So in StringKit, we've got this isLetter method, which you just pass it a string. It assumes that the string is a character. Okay, I haven't tested this thoroughly. It might break if you pass it something else, but we're not going to be passing something else. I basically have appropriated the open source .NET Core stuff from C# and converted it to Zojo. And so we run through a cascading system of methods to find out if that's a letter, and it works pretty reliably. The reason that there's an issue is that Zojo isn't great for determining whether like emojis are letters or like accented characters, and this handles it pretty robustly. Anyway, you can view it as a black box if you want. If it's a letter, then what we will try and do is add a add identifier or reserved word, this method. This is only a short method, and this will figure out we've seen a letter, we've seen an alphanumeric character, because of note, in Objo, valid identifiers must begin with a letter. Upper or lowercase, all right, doesn't matter. It's case insensitive like Zojo is. And yeah, if it sees a letter, if it starts with a letter, it could be a keyword, or it could be an identifier. So what happens here is the current pointer is pointing at the next character, right? So assuming we've got age, right, that's an identifier. A variable name is an identifier. Next token will have correctly identified that the character A is a letter, so it needs to call this method. The current pointer will be on the G. Okay. So first of all, we consume all alphanumeric characters and underscores because, like Zojo, identifiers in Objo begin with a letter, but then can contain any letter or number or underscore, as many as you want. So basically, we have a method in StringKit called isLetterDigitOr_, which essentially you pass it the next character, and it will return true if it is. And if it is, it advances. Okay, and we keep consuming until we've consumed all the characters that are contiguous. Then we work out, well, what's the lexeme? What are these characters? Okay, and that's easy. We have the source. We use the middle function. We know where it started, and we can work out where it ends, so we can get back the characters. Now the magic happens here. We've got the characters, so we just have to say, okay, well, is that a reserved word? Because if it is, well, then it's that type of token. If it's not, then it's an identifier. This stops the tokenizer from, so that means you can't use a reserved word as an identifier, which is what we want. So basically, I declare a variable called type, which is going to be an enumeration, a token type's enumeration. And then what we do is we say that type equals this reserved words dictionary, okay, which is a dictionary on the Objo module. We'll look at it in a second, and we're going to do a lookup on it. We're going to look up the lexeme. If we find the lexeme, so this reserved words dictionary, basically the keys are the lexemes and the values are the token type. And we'll just have a look at the code in a sec. So basically we say, okay, type. Look up this lexeme on the reserved words dictionary. If you find it, that's the type. Okay. If you don't, then default to using an identifier, to the identifier token type. So let's take a look at reserved words. So we'll just go to reserved words, and you'll see it's a computed property on the Objo module. It's just a dictionary. It's a read-only dictionary. And in the getter, we do this trick that we've done before. We declare a static dictionary and we initialize it and then we return it. And that means the first time we access this property, it will be slow. Well, not slow, but it has to initialize the dictionary. But subsequent calls, it doesn't reinitialize the dictionary. It just uses the static one it already has. So it's really quick. And I have hard coded in all of Objo's reserved words. Okay. I've also put in true, false, which are booleans, and nothing, which is like nil, but in Zojo, but I like nothing, sounds a bit better than nil. Okay, so the lexemes are here as keys, and as values we have the token types. And that's it. So we know the type. If the type is an identifier, then we just make a new token of type, which is identifier, with the token start, the line number, and the lexeme we computed. Otherwise, we don't need the lexeme because, the and token type, it's just an and. The then token type is just then. We don't care about the characters. So in this situation, we just return a new token of type type, i.e. the one we've just computed, starting at token start on the current line number. And then we're done. And if you go back to next token, you'll see that the only last part here is an error. Basically, if we get here and we haven't matched the character, okay, well then we don't know what character it is. Okay, it's a bizarre character we've not thought about that isn't valid Objo code, so we just throw an error. And then that should be the tokenizer finished. So I think what we'll do is I'm going to stop the video here, and then we'll do another video where we will make a little UI for us to type some Objo code and see in a list box the token outputs. Okay, so I hope you find that useful, and fingers crossed it's going to work when we actually make the UI. See you in a minute.